Welcome to our second session with Hot in Math. Before we start, let me share with you a quick flashback of our first session. Our school challenge of practice is:
students need to use high-order thinking skills when communicating their thinking.
Also, we mentioned that
we need to use questioning to stimulate mathematical thinking. Also, we know how to evaluate questions, how to transfer low-order questions to high-order questions, and what the 4 types of questions.
But in this session, we are going to talk about
math memorization.
Before we start, let's hear scientists' opinion about math memorization.
Memorizing the answers to sample math problems, such as basic addition or the multiplication tables, marks a key shift in a child's cognitive development because it helps bridge the gap from counting on fingers to complex calculation according to the new brain scanning research.
Great! But if you are teaching a grade 3 IEP student that he cannot memorize timetables, especially 9 timetables, what can we do? We cannot force him to memorize, or we cannot use magic. So, do you think there is a solution? Yes! Shortcuts is the solution. But be careful. Shortcuts are good and bad. So let's start with the good news. Why shortcuts are good? With shortcut, student can save a lot of time. Also, as a teacher, I can help the grade 3 student to find an answer for 9 times 8, for example. So let's see how we can help the student to find the answer of 9 times table without memorization.
So our question is, what the answer of 9 times 8? In this case, we're going to ask the students to hold down the 10 fingers on their desk, and we can ask them to imagine that these fingers are numbered from 1 to 10, as you can see on the screen. And because we are dealing with a shortcut of 9's timetable, so we need to neglect number 9 and focus on the other factor, which is 8. In this case, we're going to hide finger number 8, and we can ask ourselves, how many fingers at the left side of the hidden finger? As you can see, it's 7, so we're going to say 7 tenths. And how many fingers at the right side of the hidden finger? As you can see, is 2, so we're going to say 2 ones. That's why 9 times 8 equals 72. Easy, right? Let's see another example. Again, we're going to ask the student to hold down their fingers and imagine that they are from 1 to 10. And our question now is 9 times 5. And as we said, we need to neglect 9 because we are dealing with a shortcut of 9 times table. And let's focus on the other factor, which is 5. So let's hide finger number 5 and ask ourselves, how many fingers at the left side? As you can see, I have 4, so 4 tenths. And there is 5 fingers at the right side, so it's going to be 5 ones. That's why 9 times 5 equals 45.
And now, let's see why shortcuts are bad.
Shortcuts are counterproductive when they do cause children to shut down their thinking.
Not a problem.
So, we should encourage students to experience the discovery of the concept behind the shortcut. If we teach concepts rather than offer students memorize shortcuts, students will retain more information.
So, if we teach the concept and the idea behind the shortcut, in this case our shortcut will be 100% productive. So please, when you teach to the student any shortcut, you need to explain to them the concept. So let's see together what the concept behind the 9 times table shortcut.
So let's start another example. 9 times 7. And as you can see, we're going to use the 10 fingers numbered from 1 to 10 as usual. And we know from now that we need to hide finger number 7. But to show the idea, we can ask the student, what is the timetable next to 9 times table? For sure, it's 10 timetables. And all students, they know that 10 times 7 equal to 70. That means 9 times 7, it has to be less than 70. And the tens in this case is going to be the 6 tens. That means the answer has to be 60 something, but we don't know the answer. So let's focus with the difference between 7 times 10 and 7 times 9. As you know, the difference is the factor 7. So the factor 7 is the difference between 70 and the number that we will get it from 9 times 7. So if we reduce the 7 from the 70, we will get 63. And that's why we have 3 fingers at the right side, and that's why the answer is 63.
So now, what about the junior students? Can we teach them shortcut too? For sure, yes. Let's see another example with 11 times table.
I have a question, 32 times 11. As you can see, the 32 has 2 digits, 3 at the left side, 2 at the right side. Let's repeat the same thing again. Insert the 3 at the left side, insert the 2 at the right side with one condition, that we're going to leave small space between the 3 and 2. So we're going to insert the sum of 3 and 2 in between to get 352. Can you imagine? 352 is the answer of 32 times 11 without doing any calculation. Let's see another example. 25 times 11. Again, the 25 has 2 digits. We're going to insert the 2 at the left side. We're going to insert the 5 at the right side with one condition, to leave a space in between to insert the sum of 2 and 5, which in our case 7. So the answer is 275. So let's see now the idea behind this shortcut. Let's do it step by step as we are doing in class. 32 times 11. 1 times 2 is 2. 1 times 3 is 3. And again in the second line, 1 times 2 is 2. 1 times 3 is 3. If you notice here, when we're going to add this number together, in the middle there is 3 plus 2 equal 5. And that's why we need to leave the space in the middle and to add 3 and 2. So as you can see, it's very clear why we are doing that on our shortcut. Let's see another number, 85 times 11. This is a large number now, and we'll see how we can solve it with the shortcut. So I'm going to repeat again, 8 at the left side, 5 at the right side, and in this case we need to leave a space to add the sum of 8 and 5. But in this case we have a small problem, that 8 plus 5 equals 13. In this case I'm going to insert the 3 and carry on the 1 and add it to the 8, so it's going to be 935. And if you see the idea behind the shortcut, we're going to do it again. 1 times 5 is 5, 1 times 8 it's 8, and in the other line 1 times 5 it's 5, 1 times 8 it's 8. And notice now that when we are adding, in the middle we have 8 plus 5, which is 13, and that's why we have to carry on the 1 and add it to the 8, so it becomes at 935.
So our conclusions are:
the world does not need more robots. Asking children to mindlessly follow an algorithm is not teaching them anything more than how to follow instructions. That's why it is in the best interest of students everywhere to make the focus of mathematics critical thinking.
in fact, if students do not understand, they are not doing math. Thank you for your attention and hope to see you in our third session, Hot in Math.